Okay, so our next unit of study is going to be a huge algebra topic called functions. This really right here is sort of like the meat and potatoes when it comes to understanding Algebra 1. So much of algebra revolves around functions, and we'll probably be spending the next 2 weeks studying this. It's a really, really big topic. For today, I have one goal in mind, so I'm going to try and keep this video a little shorter, and it's just really understanding the difference between what is a relation and what is a function. So we just really want to make sure that we have a good solid definition and a good understanding of what a function is. And I'm going to start here with a little simple example, a little simple graph here that we can sketch. And what you're looking at here is the first quadrant of the coordinate plane. So right away, when I say the word function, graphing should come to mind. The functions are a form of graphing. And basically, whenever we graph, we're considering two variables. There's always a relationship between two variables whenever you're looking at a graph. It could be a bar graph, it could be a line graph, it could be a histogram, but there's always a relationship between two variables. Now, in this instance here, we're comparing two things, the price of steak, which is graphed along the y-axis, and then the weight in ounces, which is graphed along the x-axis. So we're comparing these two things. So ask yourself, think about if you've ever been to the grocery store and if you've ever purchased meat in the meat department, what is the relationship between weight in ounces or pounds or whatever and how much you end up paying for the steak? There is a relationship there. What do you think it is? Now, this one's pretty simple. And, I don't have any numbers graphed here, so I could really just, freehand this any way I want. But I'm going to make a linear graph. So I'll switch to my line tool here. And I'm going to start it at the origin because this is 0, 0. In other words, for 0 ounces, I'm paying $0. That should make sense. And you would see something sort of like this. In other words, the more you pay, the more you buy the weight, the larger the weight of the steak you're purchasing, the greater the price. And that should be a fairly obvious example. The fact that the graph is linear, meaning it's a perfectly straight line, says that the price is constant. So it's not like fluctuating. It's a constant price. For example, $9.99 a pound or something like $15 a pound or $20 a pound if you were purchasing something like filet mignon. You could also have, if you were comparing steaks, you might see another steak that has a graph like this, where it also starts at the origin, but is not quite as steep. Now, what do you think that's saying about these two steaks? If I call these, like, for example, steak A and steak B, what do you think's we'll make a comparison between them? Well, steak A is more expensive per pound, right? Because for the same amount, let's say if this were 5, right? If this were 5 on my x-axis, well, 5 pounds of steak is only costing you this much for steak B, but it's costing you a little more for steak A. Okay, so that's a very simple example of what a function is. Now, here's another one. This one is not going to be a linear relationship. It's a function. There's a clear relationship between temperature and time over a 24-hour period. So think about it this way, like the day, let's say if the day begins at like 6 a.m., what happens to the temperature, generally speaking, over the course of the day? And if you want to try and sketch this one on your own, go ahead and have a crack at it. You might start it here. The temperature might start somewhere around here. Again, we're not using numbers, but remember, all we know is that temperature is on the y-axis, and we're assuming that it's not 0 degrees at 6 a.m. Maybe this is like now. Maybe it's like, it's just about June. And okay, so what's going to happen to this temperature as the day goes on? Well, it's probably going to warm up for a bit, right? So it's going to start like this. And then what's going to happen is it's probably going to level off, right? Because as you get to, it's going to keep going up. And then as you get to like 2, 3 o'clock in the afternoon, it starts to level off. And then the sun sets, right? So that temperature starts to dip. So now it's going to gradually, come back down. Maybe you can get a little bit colder. 2, 3 o'clock in the morning is going to be a little bit colder than 6 a.m. So you would see a graph that is a function, and would look something like this, sort of like a bell curve. So the way we would phrase this, we would say that temperature y is a function of time, our x value. In this first example, we're saying that the price of steak is a function of the weight that you buy. It does depend upon how much you buy. Okay, so one more example like this. Here's a graph of a function for you. It's called going to a concert. It has distance traveled on the y-axis, and then time is graphed along the x-axis. Now this is the whole evening, right? So you're starting at your house, right? So distance traveled. This starts at the origin because you haven't even left your house yet. So you haven't started the timer, and you're standing on your front doorstep. Okay, well, think of a little story here. What's going on? What could be going on in this graph? There's a lot of things. You could be creative with it, but think about what this graph might be saying. Here's one example. You could say, okay, we drove to the concert and we didn't get stuck in traffic because we drove at a constant rate. We stopped. We're at the concert. So here, the distance traveled is not changing as time passes because, we're not going anywhere. We're at the concert. So this is the commute to the concert. This is us at the concert. Then we come back home, right? So when the concert's over, you leave, but we're not bringing it back down. We're going up still because we're just counting. This is total. We're saying this is like total distance traveled. So whether we're going to or fro, it's just total distance. Well, we're coming back home now, and now we're home for the rest of the evening. Some of my other students say, okay, you're driving. Oh, then you get stuck in traffic. Right here, you're in a traffic jam. And then you have to step on it again. Now you're going even faster because you're worried about being late. And then this flat part here is when you're actually at the concert. Okay, so we've seen some very simple examples of functions here, all of which are graphed in the first quadrant. The last thing for this video is some notes, and you're going to want to write these down because this is going to be terminology that follows us through the rest of this chapter. So here it is. I'll just go over it very briefly. A relation is a set of ordered pairs. So any set of points that are thrown onto a graph, regardless of where they are, regardless if they have any real relationship, that's called a relation. So all of these are relations. This is a relation, this is a relation, this is a relation. Now, this breaks down to two things. There are two other terms you need to know with that. Domain, the x values. So if we refer to all the x values collectively, so whether it's like, if we're talking about time, 2 hours, 3 hours, 4 hours, all of those x values are called the domain. It's just a fancy term given to the x values. The y values, meanwhile, are called the range. So you're going to see these words a lot. It's very important that we understand what they mean. They're not complicated. We just need to know the words. Domain is your set of x values. Range is your set of y values. And finally, I want you to write this down, and this is where I'm going to leave you. Function is a relation. So a function is a type of relation where the domain values do not repeat. In other words, x does not repeat. Now there's a lot of different ways that we can understand this, and we're going to really build on this right here. So this, when we meet today, this is what we're going to be working on, and we're going to look at lots of different graphs and diagrams, and we're going to be asking ourselves this basic question: is this a function, yes or no? For right now, copy down this definition, and I'll see you in a bit.